All right, thank you. Hi, everyone. Welcome to the talk. And I'm really happy to be back on stage again for ETHDenver 2025. And today, we're going to talk about unlocking Rust for smart contract. All right, so a little bit about me. My name is Mahsa. I'm an integration engineer at Offchainlabs. We're the initial builders of Arbitrum. It's Arbitrum, for those of you that you don't know, it's an optimistic rollup solution for scaling Ethereum. So we have been scaling Ethereum for years. And now Offchainlabs is the service provider to the DAO. So we work on code base, protocol upgrades, we provide tooling and those things. I'm also doing PhD on DeFi and DeFi security risks at Concordia University in Montreal. And these are my social. Feel free to reach out to me after the talk if you have any question about the talk or you want to talk about Arbitrum in general. All right, so who here have written code in Rust, except those two who have worked on Stylus for a while? Okay, all right. Okay, so for those of you that you did and those who didn't, I have to say that Rust is all about memory safety and performance. So it has a lot of great advantages, including memory safety, as I said. So in Rust, there's no null pointers, there's no buffer overflows, and there's no undefined behavior. And this is a huge security deal. And Rust is also incredibly fast. So it has an execution speed really high, even close to C. And it has great tooling around that. We have Cargo, Crates.io, and we have extensive debugging and testing frameworks that allow developers to write code in Rust, and they're also able to debug really easy. And on top of these, Rust has been widely used in major system programming for years, including Linux and browsers like Firefox. All right, so if Rust is such a powerful tool, why haven't we used it for smart contract from the beginning? And the answer lies in how Ethereum was designed. So Ethereum runs on top of Ethereum Virtual Machine, EVM, which itself initially was designed around Solidity and Viper. So if you want to run a smart contract on top of EVM, you have to actually write it in either of these languages, I mean Solidity and Viper, and then it compiles down to EVM bytecode. And the problem is Rust doesn't get compiled to EVM bytecode, and instead it's compiled down to WASM or machine code, and these are not directly supported by EVM. And because EVM was designed around compatibility rather than performance, it has a lot of gas restrictions and computational overhead that make a lot of smart contracts, the heavy ones especially, to be really expensive to run on chain. Yeah. So now we have Arbitrum Stylus. It is the next generation programming language for all of the Arbitrum chains. And it actually enables smart contract developers to write smart contract not only in Solidity, but it's in Rust, C, C++, and more. And Stylus is actually a game changer because we just talked about Rust, a lot of advantages, and we know that Solidity is all about security and decentralization. So with Stylus, developers get the best of the both worlds. So they're able to run smart contract in a very fast and cheap environment while on Ethereum compatible chain, and it is fully decentralized, of course. So does that mean that you have to choose between WASM and EVM? And the answer is absolutely not. So what is really cool about Stylus is that it enables multi-language smart contract on a single chain. So you have one single chain, you can write as many smart contracts in any of those languages, Solidity, Rust, C. And then these contracts, although they're written in different languages, they're fully composable. So they can talk to each other, they can interact, they can call each other without you even noticing that. And what is really important is that Stylus is not a new chain. It's not a new L2. And instead, Stylus runs inside Arbitrum Nitro Stack, the technology behind the Arbitrum chains. And because Arbitrum chains are fully interoperable with Ethereum, any smart contract that you write in Stylus would be composable with other applications that are running on Ethereum blockchain. And we call this EVM Plus, and that means we don't want to replace or we don't want to abandon Solidity, and instead we want to extend the ecosystem. We want to open the doors and bring a lot more community inside and let them write code on EVM compatible chains. And yeah, so as I said, we call this EVM Plus because Stylus introduces two composable VMs that they run next to each other. So on one side, we have like the EVM, the traditional one that runs Solidity smart contract. And on the other side, we have the WASM that runs Rust, C, and C++. And these two, they basically share one state tree and one database. So honestly, like, there's seamless execution that is going on between them, and they're fully composable. Yeah, so some breakthroughs. As I said, Rust is incredibly fast, so Stylus is really fast, and it has faster runtime with WASM execution, and it has better compiler optimizations with Rust and C. And we did a lot of experiments and benchmarking, and we found that Stylus is around 70 times faster in execution than Solidity. This is huge. And because of all these great advantages, Stylus enables what was previously impossible on-chain. So right now with Stylus, you can do a lot of heavy cryptographic functions that were not previously possible. You can do bridges at lower cost. You can do more efficient execution for gaming and AI. And you can even do L1 precompile experimentation for advanced Ethereum research. This is really more targeting researchers. And more breakthroughs. Right now, there is around 20K Solidity developers in the world, but we have 3 million Rust developers and 12 million C++ developers. So as I said, we're not abandoning Solidity, and instead we want to open the door. We want to expand our community and users, and we want to bring more users on-chain. All right, so now that we understand why Stylus is exciting and all, we have to know how it performs in terms of execution and cost in a real-world scenario compared to its Solidity counterpart. And the best way to do that is through benchmarking, and you can do that by running the exact same computation, both in Solidity and Stylus, and then you compare the gas cost and execution speed. And for the sake of this presentation, I chose matrix multiplication because it's just such a very heavy computational task that I thought it would be cool to see how it kind of differentiates Stylus from Solidity in terms of performance and gas cost. So here's the QR code that takes you to the repo. It contains all the code for both Solidity and Stylus implementation. I also included 2 scripts that encapsulates everything for you. You just need to run the script, and it does everything for you. You're able to get those numbers that I'm going to walk through in the next slides. All right, so let's start with the Solidity implementation. So we had to generate matrices online, right? So we implemented on-chain pseudo-random generator on Solidity to populate these matrices on-chain. And the results show that it failed beyond 40 by 40 due to out-of-gas errors. And that comes from costly dynamic memory allocation and computation in Solidity. And on the other side, we have the Stylus implementation that we implemented the same on-chain pseudo-random generator for populating the matrix. And Stylus leverages Rust WASM execution, and it inherently avoids Solidity's high gas costs from dynamic memory allocation. And our results show that Stylus is 99% lower gas costs compared to Solidity. This is great. And it can even scale beyond Solidity's limit, and it could handle really larger matrices a lot more efficient than Solidity did. So when implementing these two instances, I faced some challenges, especially when I was working on a Solidity code. So first off, it turned out that matrix generation alone burned too much gas. So on-chain matrix generation was so expensive that it didn't even let me get to the multiplication. So it hit the gas limit. So the solution that I attempted was I tried to separate the generation from the multiplication, but still generation failed. So the solution for that I came up with was instead of storing those matrices in contract storage, which is really expensive, I used event logs to avoid high gas fees. So that made generation feasible, but still multiplication failed at size 40 by 40. And yeah, so it turned out the multiplication, as I said at the beginning, it is a really heavy computational task, and it is a real bottleneck. So it costs too much gas, even with those storage optimizations that I did. And I was not able to go beyond size 40 by 40, and it makes large-scale computation infeasible in Solidity. So yeah, these are the challenges that I faced. Expensive matrix generation on-chain. I used event logs, even didn't really fully solve the problem. And it turned out that multiplication was the real bottleneck. So Solidity struggles with large on-chain computation. And it is really not practical for heavy workloads. We have the example here, which is matrix multiplication. So how Stylus tackles all these challenges that I just walked you guys through. First off, Stylus had very efficient matrix generation. And because it is Rust and WASM execution, makes on-chain random generator really cost efficient. I didn't have any problem with that. Stylus dynamically allocates memory, and it avoids all those really heavy storage costs that Solidity had. And yeah, we were able to generate those matrices on-chain without hitting any gas limit. And yeah, we had optimized storage management. So as I said, Stylus efficiently stores matrices in memory instead of relying on expensive contract storage. So there was no need for me to take that extra step of using event logs as a workaround. So storage costs remain low, even though we used a very large matrix, unlike Solidity. And Stylus even solved a real bottleneck, which was the multiplication itself. So it executed matrix multiplication at a fraction of Solidity's gas cost, and successfully multiplied large matrices. It can go even beyond 70 by 70 without hitting the gas limit. And storage costs remain low, even for large matrices, unlike Solidity. And what is really exciting about Stylus is that we have smart caching. So Stylus itself introduces something called Cache Manager, which what it does, it kind of stores the frequently accessed contract in memory. And so every time you call that contract, it loads it from memory rather than storage. So it makes the costs really cheaper than normal. Yeah, so this is the plot that I got for the gas cost for doing the matrix multiplication for both Stylus and Solidity. As you can see, Stylus uses way lower gas for the same operation on chain, and Solidity's gas cost increases exponentially as the size of matrices grow. And honestly, I couldn't go beyond 40 by 40. I got out of gas error, and I hit the gas limit as well. But Stylus could go beyond 70 by 70. Yeah, so Stylus exploded in gas costs and failed at 40 by 40. And yeah, if you run those scripts that like the QR code was there, you can see that Stylus can go beyond. So honestly, there's no limitation for that. And yeah, Stylus scales smoothly, handling even 70 by 70 matrices efficiently with much lower gas costs. And yeah, so its stylus gas usage is orders of magnitude lower than Solidity. So our numbers show that it is around 97 to 99% cheaper. And again, as I said, this is the repo. Please feel free to go check it out and run the code and contact me if you have any ideas or like any feedbacks or anything. And we have some tooling and resources for Stylus. So Stylus has been alive for quite a while now. We're actively working on that. We have a great documentation around that. Feel free to go check it out. We have Stylus by examples where you can find basic and a little more complex examples in Stylus if you want to start experimenting. We have Stylus SDK that makes things really easy for you to experiment. And there are some examples in that repo as well. I do encourage you to go check it out. And at the end, if you have any question, any feedback, or anything in general about Stylus, do feel free to check out our Stylus chat. And yeah, we regularly check the chat, and we try to be helpful to the community so that you can try Stylus. And with that, I conclude the talk. Thanks for listening.